Here we have a GM 2.4 liter Ecotec engine on the stand. Now, as you can see, there's been some lack of maintenance on this thing. And as we're talking about the VVT system here, one of the most important things is maintenance. Need to get rid of this sludge. And so you can understand why this thing was probably found in the junkyard. Well, in the front of the engine here, we've got the valve cover off, and you'll see the two different cam actuators here. We've got the intake and the exhaust actuator. So I've got a brand new one here. They're actually the same for both cams. So I've popped the plastic cover off of one of these, and you'll see the return spring in there. And now if I had a little better grip here, you would see I would be able to decouple and move from the sprocket, the gear part, and move the part that's physically attached to the camshaft here. If we look on the back side, you'll see a little alignment dowel that goes inside on the camshaft. But these two pieces decouple and cause our cam advance or retard. The control of that is done through these two different solenoids here. Now with the valve cover on, there's a little opening here, and so the technician can unbolt these two bolts and remove these solenoids. Now I do a little bit of prying and pulling to get these out of here. And if you look at the screens in here, they don't look too bad, except for you'll notice some sludge there. Again, not a big surprise considering the state of health on this engine. That's a bad sign. Now, as you may recall, the engine oil is going to enter in. The solenoid will be cycled and allow the oil to go towards the advance or retard cavity of the passageway on the actuator there. So we can see the exhaust solenoid as well. Got a fair amount of sludge buildup on this one too. Now you can see I've got my replacement solenoids here. Much cleaner, shinier, and you'll notice the tight tolerance fits here and precision machinery. One thing you might notice is the different colors here. And no, these are not interchangeable. If you look closer inside there, the connectors are different shape. So this is going to go to the exhaust side, and this one will go to the intake. The position of the camshaft is determined by the PCM using calculations monitoring the crank sensor as well as the two variable cam sensors. So you see the crankshaft sensor here is located on the side of the block below the oil filter housing, and the engine starter would typically be here. And of course we have the intake manifold typically hangs down in front of here as well. So it's much easier to see where it's located. Now we have one crankshaft, but there's going to be two separate cam sensors. So if we look on the back side of the engine here, you see the back of the intake cam, and we've got the high pressure pump for the GDI fuel system. And then off the back here, we've got the cam sensor on the intake side. So as I zoom in, you can see the intake cam sensor there. And so here, as we compare a new one to it, we can see how that gets just one bolt, bolts up, and goes on the intake side. This one's relatively accessible. Now let's take a look at the one on the exhaust side. Now as we look at the back of the engine here, you can see a couple different notches on the camshaft here. That's what this cam sensor is going to read. The one on the intake cam looks very similar to that. And so you'll see where the cam sensor is located here. And I can pop it out, and you'll notice again a lot of sludge buildup on this particular engine. So pop it back into place there. Of course, this looks a lot easier without all these coolant hoses in place here. But hopefully now you get a good understanding on this particular 2.4 liter GM engine, how the variable cam timing operates, as well as how it's monitored and controlled by the PCM through the use of the sensors, as well as of the solenoids and the actuators or cam phasers themselves.